So we got a bird traveling 30, is able to travel 30 meters. So we got a bird. It's going to travel 30 meters. So that's a displacement. It does so in 15 seconds. So notice, we're using the same bracket to be time and displacement. Because when did the time happen? From here to here. When did the displacement happen? From here to here. And we know the bird is flying this way, okay? And we don't know what the velocity is because our question word says velocity. What is the velocity? At what velocity is the bird flying? It's not a 3, that's a question mark. Okay? Formula. Triangle. V delta D over T. What are we looking for? V, so cover it up. So what's our equation? V equals delta D over T. So now we're going to solve. V, I don't know V, so I got to write it. Delta D is 30 meters, parentheses. My time is 15 seconds, parentheses, equals 2 meters per second. And I usually put a box around it to say that that's my final answer. Now, some of you that are really, really good at math are going to be like, Mr. Franklin, I knew that as soon as I read the problem. Me too. But that's not what this is about. This is about, can you show what's happening so another scientist can look at it and go, actually, you made a mistake here, and it's happening in a different direction. And now you can work through the problem and figure out what's really going on. Okay, so that's why we do it this way. So we've got to always show the work. All right, welcome back. Let's do a couple more KUFs, and then you'll have some practice by yourself. KUF. Okay, a toy car traveling at 0.5 meters per second. So we got a toy car traveling at 0.5 meters per second. That's a velocity. Okay, it travels 5 meters forward, so it's going to go a displacement of 5. And how much time does it take? So time equals question mark. What's our unknown? We're looking for time. Time equals question mark. What's our formula? Sorry, my letters are off a little bit, but it's okay. Triangle, V, delta D, and T. So what do we cover up? Cover up the T. What are we left with? Delta D divided by V. So T equals delta D divided by V. Now we're going to solve. I don't know T, so I write it down. Delta D is 5 meters in parentheses divided by V, which is 0.5 meters per second. Please use a calculator because it's not going to be what you think it is. So let me go ahead and follow my own rule because I always mess this kind of problem up. Let's do this. Clear. 5 divided by 0.5 should be 10. Yes, it is 10. It is not what you think it should be. It is 10. What are the units for time? Time is measured in seconds, so it should be 10 seconds. Now, mathematically, what's happening? We're dividing by a fraction with our units, so if we multiply times the reciprocal, meters cancel, and we're left with seconds. If you want me to really explain how that is and much slower, you can come see me in tutorial time. But we're measuring time, so the answer is measured in seconds. Okay, so we've done one of each. We've done a find velocity, we've done a find time, we've done a find displacement. Okay, so now do the you try, and you can check your answer. Please try it by yourself before you check your answer. It's called the you try so that you can actually try the thinking, because it's a lot different when suddenly you're by yourself and not watching me do it on the screen. All right. So, at the end of the day, I hope that you can define velocity. So what is velocity? Speed and direction. What are its units? Meters per second. I can differentiate between constant velocity and acceleration in a position graph, table, or dot diagram. Constant velocity, straight lines on a graph. On a table, even pattern. On a dot diagram, the spacing between the dots will be the same because each dot is a tenth of a second, a tenth of a second, a tenth of a second, or 1 second, 1 second, 1 second, okay? Constant speed. If it's not constant, it has to be acceleration, okay? I can use the velocity equation to solve for an unknown. I can do my KUF, and I can use this equation to solve for whatever is missing, okay? You have some practice problems to work through. Please, please, please do those. Please show your work. And if you get stuck, do as much as you can, because that's what I'm going to ask you. I'm going to go say, okay, well, go ahead and draw your picture. Okay, so now what's missing? And so we can have a conversation. So do as much as you can. If you are stuck on this, that's fine. Do this part for all the problems that you can do. If you can do this part, but you don't know what's going on here, well, do what you can, okay? If you know how to do the math, but you don't understand the picture and what I'm doing here, well, do the math, but show your work, and then we can work on the picture. But do what the part that you can do it by yourself, try it on your own, get help from your friends, yes, ask them how to do it, but you're gonna have to do it on your own on the test, okay? Alrighty, that's all I've got, so I will see you in the next video.